Hi guys, welcome to our first video in chapter 11, our chapter all about the mole. And in our first video, which is video 11.1, I'm going to start by talking about how chemists can count matter. So to begin, let's consider some non-chemistry examples, right? So we have these things in our world that we call counting numbers. So for example, if you talk about a dozen, you're talking about the number 12. So if we were to say maybe a dozen eggs, we know that the word dozen means 12. So we're talking about 12 eggs. Likewise, a ream, this is usually used with paper. So a ream of paper refers to 500 sheets. A pair is 2, triple is 3, right? So we have these words that mean a specific number, and those words are called counting numbers. Now we use those because they make counting objects a lot easier. It's way easier to buy paper by the ream instead of for the individual sheet. It is also easier to buy eggs by the dozen as opposed to buying individual eggs. And so those are some everyday examples. And chemists also deal with things that are fairly hard to deal with on the individual scale. We deal with atoms. So atoms, as you well know by now, are really tiny. And we actually can't measure them in lab because they're too small. So instead, chemists have to come up with a way to measure the number of particles in a substance. This is extremely useful for things like chemical reactions, in which you're looking at individual particles getting together and forming a reaction. If we want to do that on the bulk scale, we still need to consider the amount of particles actually participating in the reaction. So chemists came up with what's called the mole. So I have that right here, and I'm going to highlight this. So the mole, which is abbreviated MOL, so that's the unit that you'd use in a chemical reaction, is the SI base unit used to measure the amount of a substance. So it is exactly the number of carbon atoms in 12 grams of pure carbon-12. So all of the particles in this sample have a mass of 12 AMU. If we take 12 grams of it, we are going to have 1 mole of that particle. And so through experimentation, scientists discovered that a mole of anything contains 6.02 times 10 to the 23rd particles. So I'm going to highlight that as well. So make sure that you're writing down, especially these highlighted parts in your notes, because these are the key concepts of what we're talking about here. This number, 6.02 times 10 to the 23rd, is called Avogadro's number after the scientist who discovered it or played an important role in its discovery. Specifically, Avogadro talked about the number of particles the volume of 1 mole of gas, which we'll talk about later. But down here, I just have an example. You can see we need to talk about the mole because each individual atom in our samples have a different mass. So we can't just measure 12 grams of like water and assume we have the same number of atoms as we would in 12 grams of like copper. Anyway, I think the more useful part of this is going to be looking at how we actually use the mole, right? So let's look at 3 examples here. And actually to start, I'm going to move away from the mole and talk about a dozen. And so for my first question, I want to ask, how many roses are in 3.5 dozen roses? And how do I work out this question? So I know right off the bat, I'm going to need this 3.5 dozen roses. It's pretty important. So I'm going to just highlight that and say, okay, I start with 3.5 dozen roses. Cool. And then I know, okay, if I think about what I'm going to do to this mathematically, I know that in 1 dozen, I have 12 roses. Now, look at the way I've set this up. This should look very similar to a conversion factor that we would have seen way back in the beginning of our year. I'm using fractions to multiply, so I can see I have a dozen in the bottom and a dozen in the top, and those will cancel out. And I'm left with just the unit roses, right? So a dozen roses. So our dozen roses cancels all the way out, and we're left with just roses on the top. And of course, our answer, 3.5 times 12 divided by 1 would equal 42 roses. So the key act in this problem solving example was to use my conversion factor, which I got from my counting number, right? I knew 1 dozen was 12 roses. Well, likewise, if I look at my next example, I know that it asks how many particles are in 3.5 moles of sucrose. Well, I'm going to make a note here. Moles 1 mole is 6.02 times 10 to the 23rd atoms or particles. So with that information, now I'm going to be able to solve the second question in a fairly straightforward way. So let me scroll down a little so I can see. Cool. So it says, how many particles in 3.5 moles of sucrose? Well, I'm going to start by writing out my 3.50 mole sucrose. And I'm going to multiply that by a factor. Well, I already set up here that 1 mole, and I'm going to put that on the bottom of my fraction so it will cancel. 1 mole of sucrose. And we said that 1 mole contains 6.02 times 10 to the 23rd particles. 23rd particles. Now, I would recommend that you pause your video here and make sure that you can actually put this into your calculator and get out the correct answer here. 3.50 times 6.02 times 10 to the 23rd. Again, pause, plug that in, and make sure that you can get our answer, because we see our units, which are moles of sucrose, cancel out. We're left with just particles. And our answer is 2.11 times 10 to the 24th particles. If you really think about what that is, you take a 2 and you put 1 and then 22 zeros after it. So it's a huge number of particles. Spoiler alert, it's about 60 grams of glucose. It's not a lot at all, less than you put in a cup of coffee. But the point is that we're dealing with very large amounts of particles. So that's why we need to use the mole. You can see 3.50 is much easier to work with compared to 2.11 times 10 to the 24th. Okay, I'm going to do one more example in this video. So let's talk about going the other way. How many moles do we have in 1.2 times 10 to the 23rd atoms of boron? So let's take a look. We start with our given information here. It says how many moles, which is what we're looking for, moles, and we have this many atoms, 1.2 times 10 to the 23rd atoms. So I'll start by writing out 1.2 times 10 to the 23rd atoms. Notice it doesn't really matter if it's boron or carbon or sucrose or whatever. When we're just going between particles and the mole, it's all the same. We're just using this mole as a counting number, right? So 1.2 times 10 to the 23rd atoms times, well, I know I'm going to need atoms on the bottom and I want moles on the top. So I'm gonna say 1 mole had the number of particles of 6.02 times 10 to the 22nd atom. I'm sorry, the 23rd atoms. Okay. And so I do my math. I take 1.2 times 10 to the 23rd times 1, divide that by 6.02 times 10 to the 23rd. And if I do that math out, again, make sure you pause and that you can get this on your own. But I'm going to get 0.20 mole of boron, which means I've got 0.2 times 6.02 times 10 to the 23rd moles, particles of boron, right? So I've got that specific number of boron atoms. All right, guys, that's it for this video. Thank you for listening, and I'll see you guys in the next one.